welcome to Ocean County's Barnagat Bay. Today, Ocean County is one of the top 25 fastest growing counties in the nation, population-wise. And that doesn't just mean the human population. Barnagat Bay is home to a diverse array of organisms, both in the water and on land. The estuary's ecological productivity and broad appeal make this coastal area one of the most valuable living resources in the nation. The EPA designated Barnagat Bay as an estuary of national significance as part of the EPA National Estuary Program in 1995.
Generally, the water cycle describes how water evaporates from the surface of the earth, rises into the atmosphere, cools and condenses into rain or snow and clouds, and falls again to the surface as precipitation. The water falling on land collects in rivers and lakes, soil, and porous layers of rock, and much of it flows back into the oceans where it will once more evaporate. Barnagat Bay receives more precipitation than other places do because it is a large body of water, so more water evaporates and forms clouds. The Barnagat Bay recirculates ocean water every 3 months, primarily through the Barnagat Inlet. The overall condition of Barnagat Bay is fair, based on ratings of water quality, sediment, benthics, and fish tissue contaminants. However, in the Barnagat Bay watershed, almost all water is depleted. Either the bay consumes water, or it goes to the county's sewage system that pumps it back out 3 miles to the ocean. This method works well to remove the waste from the watershed, but it puts a large strain on the water cycle, as Barnagat Bay Partnership tells us. In addition, it hinders the overall water quality, as the runoff that results from precipitation takes a longer time than nitrogen to reach the Barnagat Bay area, and excess nitrogen has a host of environmental issues that will be discussed later on. Estimated values of water quality in Barnagat Bay is 245 million, and water supply is 59 million.
The carbon cycle describes the exchange of carbon among Earth's biosphere, life, atmosphere, air, hydrosphere, water, petrosphere, soil, and lithosphere, or the rock's crust and mantle. Various carbon cycle processes happen directly on the bay. Certain photosynthetic creatures, like the famous plants that line Barnagat Bay, can also use inorganic carbon to produce sugars. Carbon dioxide dissolved in water is incorporated into the marine life food chain, and into the carbonate materials that make up the shells or skeletons of many marine organisms in Barnagat Bay, like the stripers and crabs that Barnagat Bay fishers readily hunt for recreational purposes. The carbon cycle generates a lot of profitability for Barnagat Bay. As shown by a report done on Barnagat Bay's economy, 1,720 acres of forest in the Barnagat Bay watershed have the following benefits: carbon storage, which generates $146 million, and carbon sequestration, which is when carbon dioxide is removed from the atmosphere and held in liquid form, generating $5.1 million. Forests in the Barnagat Bay watershed provide environmental benefits by regulating climate change, cooling, and air emissions control, including 7 million tons of carbon storage capacity, 246,848 tons carbon sequestration, 7,053 tons of air pollution removal, and 24,685 tons of avoided carbon emissions capacity.
The nitrogen cycle describes the general process in which nitrogen is converted into its diverse chemical forms that can be done through both biological and physical processes. As an article written about Barnagat Bay and the nitrogen cycle tells us, the most pressing issue affecting the bay is the over-enrichment by nutrients, primarily nitrogen, from surface runoff. Approximately half of the nitrogen in Barnagat Bay originates from surface runoff. Increased nitrogen can lead to a variety of water quality problems, such as eutrophication, increased harmful algal blooms, hypoxia, which is a lowered level of dissolved oxygen in the water, loss of submerged aquatic habitat, and loss of fisheries.
Here are some plants we found at Barnagat Bay. The first phylum we looked at was Anthophyta. The distinctive feature of this phylum is the flower, which is the plant's means of reproduction through pollination. This is the largest and youngest phylum of plants, which contains plants that dominate the vegetation of the world. There are two sections of the phylum Anthophyta. The first is the monocotyledon. These plants have one cotyledon in the embryo. A cotyledon is an embryonic leaf in seed-bearing plants. Other characteristics include branched leaf veins, petals with multiples of 4 or 5, and pollen with 3 furrows or pores. The second section is dicotyledonous. These groups of plants have one cotyledon in the embryo, parallel leaf veins, petals in multiples of 3, and pollen with a single furrow or pore. Another phylum we looked at was the Coniferophyta. This phylum is made up of mostly evergreen trees and shrubs. These plants tend to be tough and can survive in stressful environments, including drought, high winds, heat, and cold. Conifers have either needles or scale-like leaves. They bear cones instead of fruits, and their seeds do not have a shell-like outer coating like flowering plants. Another phylum we looked at was the Pterophyta. This group is mainly made up of ferns. Some are aquatic, some live in deserts or on dry rock cliffs. A few persist in the cold Arctic desert, but mostly the modern ferns live in the tropics. The last one we looked at was the Lycophyta. This phylum contains mostly club mosses. The stems of these plants are covered in numerous small leaves. The defining feature of the phylum is that the leaves are microphyllous. Such leaves are defined by single unbranched leaf veins. Plants with microphyll occur early in the fossil record, so few are found today.
The many organisms living in Barnagat Bay rely heavily on each other, as seen in the trophic structure. One such example of this is the extensive area of the bay that is covered with submerged aquatic vegetation, including benthic algae and vascular plants, or seagrasses. Light is essential for the growth of submerged aquatic vegetation, and under conditions of low turbidity, which is the cloudiness or haziness of a fluid, sunlight can reach the majority of the shallow bay bottom. Eelgrass is the dominant seagrass in Barnagat Bay. Lower salinity areas in the northern part of the bay also support sago pondweed. Eelgrass is an important component of the ecosystem because of its ability to convert the sun's energy into food for higher organisms. The plants contribute to primary production in the detritus-based food chain, and also indirectly through epiphytic algae that grows on the stems and leaves. Eelgrass beds create food and cover for invertebrate species, which are in turn eaten by fish, waterfowl, and larger invertebrates. The beds also provide essential spawning and nursery habitat, as well as refuge for many invertebrates such as blue crabs, mollusks, and juvenile fish.
The watershed's economic value was determined in two ways: water resources and habitat, and ecosystem goods and services. Wetlands, forests, and other watershed habitats of Barnagat Bay make up the 670 square miles of space. Ecosystems within the watershed include forests, which make up 34% of land, urban areas making up 24% of land, marine/bay areas making up 18% of land, freshwater wetlands making up 16% of land, saltwater wetlands making up 5% of land, barren areas making up 2% of land, and farmland making up 1% of land. The estimated value of ecosystem goods and services provided by the Barnagat Bay watershed is $2.3 billion. Freshwater wetlands account for $908 million, marine bay $778 million, forests $282 million, and saltwater wetlands $155 million. The natural capital value of the watershed will decrease if urban land replaces forests, which currently cover 1/3 of the drainage area. The water quality accounts for $245 million. The water supply, $59 million. Fish and wildlife, $189 million. Recreation, $1.527 billion. Agriculture, $12 million. And forests, $208 million. Yeah. Okay, so we just want to know, like, what attracted you to Barnagat Bay?
I grew up
On the bay, and also, like, this project is about, like, the ecology of Barnagat Bay, and, like, you have clams, so, like, how much, like, is your business off of clams?
clams, crabs, oysters.
Okay. Yeah. This is how you make your living?
What's that thing?
Yeah.
Oh, really? Oh, well. I'm too old. I don't have one. Clam shack.
Oh, cool.
Got clams. Got crabbies. You're live. And they bite.
Oh, no.
Oh yeah. You want to put your fingers in these pinchers?
You're like great.
No, I'm not. Clam shack's got crabs, I'll tell you. What's up, Kathy? Huh? What about the blonde with you? Okay.
This is really cool.
It's like walking in 1960. The Newark Star Ledger did something last year because it's like, oh, can I do a story about this? I mean, I've been a legal clammer since 1969, and everything is number one. State health department, federal health department, inspect all my claims.
That's awesome. Thank you.
What was that?
There are a lot of like.
Oh yeah, all local peoples. Well, when they open the bridge, you'll get tourists. Everybody's got that GPS thing, and it don't tell you how to get around a detour. It's true.
Yeah. Okay. Thank you.
These are the sizes of clams. Chowders, cherries, tops, bar choice. Hear that? I heard something like that. Chowders, cherries, topics, bar choice, and peanut. And when folks come in, they're like, what size do you need? And that's where they can say, I want the little neck, the peanut.
What's your most popular?
The little neck and the choice.
Are they all found like a lot here, or is there one that's more prominent?
What?
Is there one that's more
You
frequent?
talk too quiet, sweetheart.
I'm sorry.
Wait till you're 66 years old.
Is there one clan that's a little bit more frequent in the bay?
Everybody wants the small ones. They want the peanut, the choice. Winter time they want to make soup.
But they're the ones that are found the most in the bay?
Well, they're all mixed up in the bag.
Are these real,
Yeah, it's an anchor shark.
and was this found in Barnagat Bay?
That was a gift. I had a guy that used to go fishing and he was married. And when the wife moved in, I don't like seeing them shark teeth. So they moved in their own house and says, I gotta get rid of them. I said, "Get back over here." What's up, Kathy?
Thank you so much for letting us come.
Anything else?
I think that's it.
What's this?
I told my
Oh, you mean little Jesus?
Yeah.
Turn off.
Yeah, little Jesus.
Thank you.
The lady's doing something on the Barnagat Bay. Can we give them any answers?
About
We're doing a bio project on the ecology ecology and ecosystem of Barnagat Bay.
Oh,
So do you do a lot of fishing and stuff here?
a little bit. You know, I used to go up to the walkway or something like that. Look at that. Just to know that school park. Great.
Thank you so much. Thank you.
All right. Take care, Patty.
Evidently, the majority of Barnagat Bay's direct economic value is derived from the services provided from the ecosystem, particularly commercial and recreational fishing. Submerged aquatic vegetation, or SAV, is an important habitat for finfish and, more importantly, hard-shell clams, the most valuable commercially caught species in the area. However, hypoxic algal blooms that grow on the surface of the bay as a result of eutrophication decrease the amount of dissolved oxygen in the body of water. This leads to a decline in the population of SAV and consequently fish and shellfish. To combat this dilemma and increase the long-term economic value of the bay, scientists must utilize enzymatic hydrolysis to decompose harmful algal populations. After algae is manually removed and taken to a treatment facility, enzymatic hydrolysis can occur. Enzymatic hydrolysis is a multi-step and heterogeneous reaction in which insoluble cellulose is initially broken down at a solid-liquid interface via the synergistic action of endo- and exoglucanases. This initial reaction is accompanied by further hydrolysis of the now soluble intermediates in the liquid phase, which are further broken down to produce glucose. Through fermentation, this glucose can be used to produce ethanol, a biofuel. Using enzymatic hydrolysis, once detrimental algal blooms can be used to produce an economically and environmentally viable source of energy for the residents of Barnagat Bay.